So what we're going to look at is looking at NAT policies, and because the way you implement NAT in a Palo Alto Firewall is through policies. So what you'll do is you'll set up your NAT policies and also security policies, and the security policies and the NAT policies work together. So we're going to have a look at what NAT is, different types of NAT, source NAT and destination NAT, and also why you need to use NAT. So we'll look at how to configure NAT policies and for both source and destination NAT. So what is NAT, first of all? So, well, actually, before we look at what is NAT, it's probably worth just reviewing how the flow logic of the firewall and how it works. So a packet comes into an interface of the firewall, and the first thing the firewall does is have a look to see whether this packet is part of an existing session. If it's not, then what it's going to do is it's going to analyze the source zone and the destination zone. And in doing that, it also looks to see whether there's some NAT going on. So whether there's destination NAT occurring. It then does a security policy check to see whether that packet is going to be allowed or denied. And it'll assign a session ID if there's not already a session established. If that packet's part of an existing session, then all of this information has already been captured as a part of that session. So it'll just then go on and do packet inspection, both application level inspection and content inspection. If the packet is encrypted using HTTPS or something like that, and you've got a decryption policy in the firewall, then the packet will need to be decrypted before it can determine what the application is and what content it contains, whether that content might be, sort of malware or dodgy file or whatever. And but then what it does is it applies a security policy, and that security policy will then determine whether that packet is forwarded or whether it's not forwarded out the egress or the outgoing interface. And obviously, if it's been decrypted, it needs to be re-encrypted. So it's worth considering this when we think about what NAT is and how NAT impacts on the flow logic of the packets inside of the firewall. So first of all, there's two different types of NAT. One type is source NAT, and source NAT comes into play when you've got a client on an internal network with a private IP address that wants to communicate with a server on the internet. Because private IP addresses, say for example, this host has an IP address, this internal host has an IP address of 192.168.1.20. If that source address gets to an internet router, then an internet router is just going to drop the packet because it's a private IP address. So for this client to be able to communicate with a server on the internet, it needs a public IP address. And ordinarily, in a small network in particular, there might be a public IP address which has been allocated from an ISP on the external interface of your firewall or the external interface of your network. So what we need is a mechanism where that internal client can utilize the external IP address provided by the ISP and use that IP address to communicate with the internet. And that process is called source NAT. So source NAT essentially is the allocation of a public IP to this internal client so that it can communicate, and that packet can be routed through the internet, and then it knows to get back to the destination being this outside interface. But then the final part of NAT is to then redirect that packet back to the internal client that originated the traffic. So essentially what NAT will do is it will substitute the source IP address of the internal client with a source IP address of the external interface of the firewall, and then that then will then become the source IP, and that packet will then traverse the internet, go to the server, come back again as a destination. The destination address will be here for the return traffic. Yep. And then, but the firewall will know, oh, that traffic is NATed, therefore I'll replace that destination address with the destination address of the internal client. So that's source NAT in essence, and that's how it works. Alternative is destination NAT. Now, destination NAT is where you might have, say, for example, a web server on your internal network. And this web server also has an internal IP address. Say, for example, it was 192.168.50.100. So it's sitting in the DMZ or in the extranet zone. Yep. And what we want to do, though, is we want to publish that content on the internet so an external client can access our web server. So what we do is we NAT the destination address. So here what we were doing is we were NATing the source address. Okay, so we were changing the source address with the external IP of our network. Here what we're going to do is we're going to NAT the destination address. So the destination address of this traffic from the external internet client is going to be NATed to the internal IP of the web server. So as far as the internet is concerned, this web server lives on this address. But what the firewall will do is it will translate that address to become the address of the web server, so the web server receives the traffic. And that's referred to as destination NAT, because what we're doing is we're NATing the destination IP rather than the source IP, because the source IP will be the IP address of this remote client, and the destination IP will be the address of the web server. Yep. So it's called destination NAT. So we can either NAT the source IP address or we can NAT the destination IP address, depending on what we're trying to achieve. So these are two different types of NAT that we can use. So first of all, we'll look at source NAT and how we configure it in the firewall. And once we've configured source NAT and it's an appropriate security policy, our internal clients will be able to access the internet. So source NAT translates the original source IP address to an alternate source IP address. So you can see here we've got a client in here, 192.168.15.147. So it's a private IP. It's not an internet routable IP. But on the external interface here, we've got a internet IP. And we want to talk to this internet server, which is at 203.0.113.38. Yeah. So before NATing, this is the source address and this is the destination, because we want to get to this server. After our source NAT, what happens is that the router will, or the firewall will replace the source address with this address here. So this becomes the new source address. The destination address is unchanged. So you can see what we're doing is we're network address translating the source address. Yep. So that's referred to as source NAT. So then the internet, when this server receives the packet, it sees this is the source address. It knows its destination. So any packets that it responds with, say the HTTP response, for example, would come back to here. Oops, come back to here. So it would come back to the firewall. And then the firewall will then NAT translate that back to here. And then this client will receive its response, its HTTP response from the internet web server. So there's different types of source NAT. We've got static IP, and in static IP, we have a fixed one-to-one translation. So with static IP, you need a public IP address for every internal IP address that you're going to give internet access to. So you've got a one-to-one. And what happens is the source port doesn't change. So when we're talking about TCP traffic, we've got source port and destination port. So with static IP, the source port doesn't change. With dynamic IP, you've got basically you typically have a pool of addresses and you allocate IPs from a pool of addresses. So say, for example, you're lucky enough to get half a dozen IP addresses from the internet service provider. Then what you can do is you can use one-to-one translations. So you can provide one, where you can say, for example, your ISP gives you half a dozen IPs in a pool. Then you can allocate from that pool and you can allocate half a dozen internal clients, internet access on a one-to-one mapping from each one of those IP addresses in a pool.
Would that be like for a business?
Yeah. But it's still one-to-one and the port number doesn't change. So what that means is you can only allocate as many internal IP addresses as you have public IP addresses. So these two are only really for special use cases. What's most commonly used in source NAT is dynamic IP import. And there, what happens there is with dynamic IP import is you have a pool of IP addresses. You could only have one, or you could have more than one to allocate, depending on how many you get from your ISP. Most small businesses only get one, but you might get maybe a couple if you're lucky. And what you do is from that pool of one or more, is you can allocate to as many clients as you need, as you have internal clients. So say, for example, in this room, we've got 25 PCs that want internet access, but we only have one external IP address. What we can do is we can share that one external IP address between these 25 clients by changing the source port address. So by manipulating the source port, then and keeping track of which PC has got which source port translation, we can reuse that one IP address for all of these computers. And that's what happens in most cases is dynamic IP import. So, and here you can set the interface address as the assigned address, or you can, if you've got a different address, you can use a different address to the internet, to the interface address, the outside interface address. So dynamic IP import by far is the most commonly used mechanism. So how do source NAT and security policies, they sort of work together. So here we've got users NET and we've got an internal IP address, 15.47. Here we've got our outside interface, which has been allocated an IP address on Ethernet 1.1. Yep. So 198.51, so that's an internet routable IP. And we're going to the internet to 203.0.113.38. So when we set up a NAT policy, and we do this from policies NAT, then here we give it a name. Then we've got the original packet. So you can see here, this is the original packet. And then this information, this section here is for the translated packet. So if we look at the original packet, we've got the source zone where it's come from. It's come from users net. The destination zone it's going to, and it's going to the internet zone. We've got the source address. And here what we're doing is they're saying this will accept from any hosts on the 15 network. So 15.47 would be included in that 15.0/24. Can you guys read that? Yep, 15.0/24. Destination address going to anywhere, any service. Yep. So then if we look at the translated packet it's saying, oh, we're using dynamic IP import on Ethernet 1.1. Yep. So dynamic IP import is basically going to share this IP address of Ethernet 1.1 across all of any client in the 15 network, yeah, including 15.47. That's the NAT rule that we've set up. However, having said that, yeah, 198.51.100.22. Yep, so you can see that's the IP address which is going to be shared by all of these internal clients on the 15 network, including 1547. Now, it's one thing to set up a NAT policy, but we also need a security policy, because we need a security policy that's going to allow traffic from the user's net to the internet. Yeah, because if you don't have a security policy, then your NAT policy will do the NAT translation, but it'll be blocked by security policy. So you need both. You need a NAT policy and a security policy to do source NAT. So on the security policy, we've got from the users. If you look at the source, we've got the source zone and we've got the source address, and you can see here it's the pre-NAT address 15.0. So the security policies is apply. It's using the original IP address here, not the translated IP address.
Why is that?
Because when you're thinking about your security policies, if you weren't using that, you'd still be applying them to the source. Do you know what I mean? So it uses the pre-NAT in the source. But what it does is it uses the post-NAT zone, the internet zone, because what we're doing, if you think about it, what we're wanting to do is we're applying a security policy from the user's net to the internet. So that makes sense. And the destination, they've got pre-NAT address, but normally if the destination is the internet, normally that'll be any. And then we've got other things like application and service and all of that sort of stuff. So the NAT policy and the security policy, they sort of work together in being able to provide internal clients access to the internet. So to configure our source NAT, then we've got our NAT policy rule. So we've got our source zone, which was users net, our destination zone, which we've set up as internet, and then we can set up the source addresses. And then this provides this basically provides the match criteria that will be used to determine whether that traffic is going to be natted or whether it's not going to be natted. And then we've got our translated packet. So this is the original packet and this is the translated packet. So you can see on the translated packet, we're using source address translation. Over here, we've got for destination NAT, we've got destination address translation, but that's got none in it because what we're doing is we're doing source address translation. So you wouldn't do both. You'd either be doing source address translation or you'd be doing destination address translation. Yep. So in our source address translation, the type is dynamic IP and port. And here we're saying the address type is the interface address. The interface is Ethernet 1.1, and this is the IP that's been configured on Ethernet 1.1. So this is typically how you would configure up in the lab environment using dynamic IP and port.
Do we do a lab on this?
Yeah, there's a lab for this, yeah. So other examples are if we had static one-to-one translation, then our original packet wouldn't change, but in our translated packet, we'd have static IP, we'd have a fixed IP, and then here they're setting it to be bidirectional. So you can do bidirectional with static source NAT, which means it'll work both ways.
What would an example of use for that one be?
Probably an example of this, you know how in your home network you can do DMZ?
Yeah.
And DMZ basically says this internal device sits on this external IP address. Yeah, so this is like bidirectional. So because this is bidirectional, that's the best example I can think of. Dynamic IP translation, here we've got a pool. So the original packet doesn't change, although here what they've done is they've limited the source addresses here. And the reason they've limited the source addresses is because they've limited it to the size of the pool.
That's
yeah.
many IP addresses they've got from the ISP.
Yeah. So here they've got dynamic IPs of 198.50.100, 102 to 100, 150. So they've got 48 IP addresses. So here they've got 2 to 50. So they're saying, okay, we're going to allow 48 internal IPs to use that pool of 48 external IPs, and that way nobody misses out. Do you know what I mean? So if you don't want to have any issues, then you probably need to allocate as many internal IPs as you've got external IPs for dynamic, because there's no port mapping with dynamic. It's a one-to-one.
So one person always has to be like, what's going on?
Yeah. We can do that, and it'll just wait until one frees up in the pool. Yeah. So that's the default behavior. If you've got more internal clients than you've got addresses in the pool, then they just have to wait till an address frees up, which probably doesn't have a really great user experience.
Not at all, but it'd be funny.
Yeah. So with dynamic IP and port, you can see here that you can give your whole subnet access, because you've got even though you've got a pool here, 22 and 23, so they've got 2 IP addresses that can be shared between all of the users. So you've got, you might have, say, 50 users, internal clients on this subnet, 15.0 subnet, but you've got 2 IPs that you can share between those clients.
Will that just use whichever one?
I think it'll just share the load between the 2.
Share load balancing.
Yeah, something like that. Yeah. So there's this concept of NAT oversubscription, because the question is, well, how many ports does your firewall support? And different firewalls have a different number of clients that they can oversubscribe, port oversubscribe for dynamic IP and port. So you've got to look at the type of firewall you've got and what level of oversubscription you can use to see how many IP addresses you need to support how many hosts. And that'll vary with the firewall version, but generally speaking, it's a big number, so you don't have to worry too much. So the other option we've got, other than source NAT, where we've got internal clients wanting access to the internet, is destination NAT. And destination NAT is where we've got a server, and what we want to do is we want to publish that server content on the internet. So that we do that using destination NAT. So let's have a look at how we can configure destination NAT. So classic example here is we've got our extranet. We've got our server, www.example.com. It has an internal IP address on our extranet zone. But we want to publish this on the internet, and we will do so using this IP address, which is the IP address given to us via our ISP. So that when a client on the internet wants to connect to our server, they'll use this as the IP address for www.example.com. So if we wanted to register a DNS entry, we'd put an A record in which would register 198.51.100.22 as www.example.com, and then use the firewall to do destination NAT to put it to 192.168.16.2. Yep. So with destination NAT, if the traffic's coming from this client here, so this is the source address, and you can see here's the source address. The destination address is going to be here because it needs to be an internet routable IP, or a public internet IP. And after we do destination NAT, the source address doesn't change, but the destination address is being changed to 16.2. Yep. So that's what the firewall will do with destination NAT. So yeah, it is pretty much essentially the same as port forwarding on your home router. So destination NAT attributes, typically we're using a static IP, and we've got one-to-one fixed translations. And we're changing the destination IP, but but leaving the destination port unchanged. Notice that you can do this also by using static source NAT with bidirectional option set, which we looked at before. So it's sort of an alternative way of doing the same sort of thing. So here what we're doing is we've got translated packet, and the translation type is static IP, and the translated address is 192.168.16.2. We've got the option here for translated port. So if we want to do port translation, we can. But if we don't do port translation, then we can just, it'll just do all of the ports.
Would that be like just to force it to go from 80 to 443?
Yeah, yeah. So if we've got a dynamic IP address, in other words, we've got an IP address which is DHCP assigned, you can deal with that. So here we just, instead of going to, previously we used static IP, here what we would do is we'd use dynamic IP. And we've got also dynamic IP with session distribution. So dynamic IP with session distribution allows you to have multiple servers and allocate via round robin. So if you wanted to load balance multiple servers, then you could use a round robin load balancing method internally on your internal network. So you might have, say, 3 web servers and then use this methodology to balance the load on those different servers serving the same thing. So with session distribution means that if somebody's established a session, then it'll retain that session information, always make sure that they hit the same server and not a different server. But if you get a new session coming from an external client, it'll get routed to a different server. So it'll balance the sessions amongst those servers. So that's quite a powerful capability. Yep. So the translated address in this case can either be an FQDN, fully qualified domain name. So in other words, you might say translate www.example.com, or you might have an address object or an address group. So you can do any of these options. So how does destination NAT work with security policies? So in this situation, our traffic is originating from the internet. Its destination has to be a public IP, which is the public IP that's been allocated to Ethernet 1.1, our internet zone. The NAT translation is going to go to 192.168.16.2, which is on Ethernet 1.3, which is our extranet or our DMZ zone. So let's have a look at our NAT policy. We've got, the name of it is destination NAT from internet. Source zone is internet, so that's our source zone. Our destination zone, interestingly enough, is pre-NAT. Our destination zone is internet. So this is where it gets a little bit interesting because this is the original packet. Yeah. Our destination address is this address, which is pre-NAT. Yeah. So this is all original packet. And if you think about it, it makes sense because the original packet, the destination zone is the internet and the destination address is this address because the packet hasn't been translated yet. When we translate the packet, it's destination translation and the translated address is 192.168.16.2. Yep. So that's our NAT policy. So with the security policy, here, we're calling this security policy web server access. Source is from internet, from any address. It has to be any address because it's any address on the internet is the source. So anybody from the internet, we're allowing access to our web server. Our destination zone is extranet. So for our security policy, we're talking about applying the security policy to the extranet zone. Yeah, and that sort of makes sense when you think about it. But our address here is the pre-NAT address. So our address here is this address, pre-NAT address. And the reason for that is that that is the destination address that's going to be checked from the security policy. Yeah.
That's pretty confusing.
That's a bit confusing, I know. So I can never remember this. So if ever I go to do destination NAT, I always have to have a look and see the way it's got to be, because I can't remember it. But anyway, so here what we can do in our security policy, the application is web browsing. Yep. And the ports is application default. So that the only allowable ports for that will be port 80 and port 8080. Yeah. So here what we're doing, even though here we've got service HTTP in our NAT policy. So here we're only going to allow basically web traffic, yep, based on our service, which is service HTTP, and also here on our application, which is web browsing, and our service being application default. And we're going to allow that. So as you can see, the security policies and the NAT policies work together, because without a security policy, your NAT policy won't allow any traffic. So how we go about configuring destination NAT, our original packet would be source zone internet, destination zone internet. Our source address is any. Our destination address is our external IP address. And then in our translated packet here, we've got static IP, we've got the translated address here, and if we've got any port translation happening, we can do port translation. So for example, we wanted to expose port 8000 for whatever reason, then we could put that as our translated port, and then it would translate it back to our internet port. So you can see in this example here, our translated port, so it's listening on port 8000 here. Usually when it's listening on a port other than a well-known port.
You can change that.
Yeah. So in here, our service HTTP option includes port 80 and port 8080. Yeah. So if you want to do port translation, this is where you would do it. You know, with port forwarding, you can also do port address translation if you need to. Some home routers allow you to do that. So this is how you would do port address translation. So the other thing we can do is we can do bidirectional source NAT, and that achieves, like as I mentioned before, it achieves a similar effect. So this enables internal servers to send and receive traffic through the firewall. Yep. And it's available only for static NAT. So our translated packet, we would put as static IP. And our translated address here, 198.51.100.22. And we tick the bidirectional. So this would allow the server to receive traffic, but also to send traffic as well. So in both directions. So you can do that with bidirectional source NAT. And then you would need obviously a policy associated with that to allow that traffic in both directions. Okay, so we've had a look at both source NAT and destination NAT, but the best way to understand what's going on with these really is to have a go at the labs and do the lab. I think there's a couple of questions here. No, there's not.